Good afternoon. I, Pulkit Nayak, thank you to each and every one of you for being here with me for the third session of the Faculty Development Program on the emerging trends in the thermal engineering organized by the Department of Mechanical Engineering, Sri Shankacharya Institute of Professional Management and Technology, Raipur. The Faculty Development Program on emerging trends in the thermal engineering intends to weave a series of informative sessions on the novel findings in the field of thermal engineering. I would like to invite the session dignitaries Dr. T. N. Verma. Dr. T. N. Verma, Assistant Professor at Maulana Azad National Institute of Technology, Bhopal. He holds a BTech in Mechanical Engineering, MTech in Thermal Engineering, and a PhD. He specializes in thermal engineering and has a 7 years of experience. He is also a member of ISHMT, the Indian Society of Heat and Mass Transfer, as well as FMFP, that is Fluid Mechanics and Fluid Power. So far, Dr. Verma has published a total of 86 research papers. Sir, we beseech you to join us on the screen. Thank you, sir.
Thank you, Naik.
Sir, please.
Still, please allow me to present my presentation from your end.
Yes, sir, we have forwarded this issue to our technical team. Sir, please try now.
Now it's visible?
Yes,
Yes, sir.
Okay, and my voice is also clear?
Yes, sir.
yes, sir.
Okay. Thank you, Naik, for the introduction, and thanks from the organizing institute to call me for this FDP. And this session is related to alternative fuels, which is very it is related to our day-to-day life. Today we discuss some basic things. So the table of content is related to, first we have discussed introduction, then what are the sources of energy, like renewable and non-renewable source of energy, as we know that two types of sources of energy. Then depletion of natural reservoirs. What is the need? Why we are going to the alternative fuels? Then what are the major challenges and constraints? Then there is one slide related to emission and emission norms, that is BS2, BS3, BS4, BS5 and 6. There are basically three types of generation of fuels, generation 1, 2, 3. Some results I have shown in the current trends on biofuel research. Other than this also I am working on now in diesel RK. So it is not in the slide, but slightly I am discussing that also. And what are the testing methods like GCMS, XRD, SEM images, that we can discuss in the last few slides. Conclusion, I have not shown any result part, so it is a general conclusion. And then I think the references is there. So in the introduction, we know that the increases in energy consumption, particularly in the past several decades, has raised fears of exhausting vital natural resources. So rapid industrialization and massive growth in population has increased the dependence and use of these natural fuels. So approximately 90% of our energy requirements are met by these fossil fuels. So the studies suggested that if exploited at this same rate, so the coal reserve will deplete in the next 200 to 300 years, and petroleum deposit will deplete in the next few decades. There is one slide also for this petrol and coal, how it will deplete in the next few decades. So it is important for us to engage in research and development for these alternative fuels, so that we may not face scarcity of natural resources in the future. Now, India is the ranked 6th in terms of energy demands, but its domestic crude oil satisfies only 1/4 of our current demands. Other than this, greenhouse gas emission and global warming is also in the forefront of critical issue. So India is currently facing energy crisis with its major dependency on coal, crude oil imports to meet sharply growing energy needs of the country. So what are the causes of energy crisis in India? So basically, demand is more than supply, and this is the main cause of present power crisis. So during the 5 years plans, stress was given on the development of industries, but to cope up with that industrial development, equal stress was not given on the development of power. So most of the power stations of India are in related to thermal origin. Then there is a one more point: fossil fuels burning and combustion are also main causes of the pollution to the environment. So these fossil fuels basically are hydrocarbons, fuels, natural gas, coal. It formed from the remains of dead plants and animals. So in common, we can say the term fossil fuel also includes hydrocarbon containing natural resources that are not derived from animal or plant resources. So it is a general term for combustible geologic deposit of organic material, and it formed from decayed plants and animals that have been converted to crude oil, coal, natural gas, or heavy oils by exposure to heat and pressure in the earth crust over hundreds of millions of years. So basically, there are two types of sources of energy in this slide. So just like every coin has a two sides, head and tail. So some have advantages and some have disadvantages. So in the renewable energy, it uses sources that are continually replenished by nature, like sun, wind, water, earth heat, and plants. So these technologies turn these fuels into usable form of energy. Generally, we are converting in electricity and also heat, chemicals, or we can say mechanical power also. So today, we primarily use fossil fuels to heat and power our homes and fuels in our cars. So it's convenient to use coal, oil, and natural gas for meeting our energy needs. But we have a limited supply of these fuels on the earth. So we are using them much more rapidly than they are being created. So eventually they will run out. And because of the safety concern and waste disposal problems also. So the nation energy needs are expected to grow up by 35 to 40% during the next 20 years. So this renewable energy can help to fill the gap also. So even if we had an unlimited supply of fossil fuels, using this renewable energy is better for the environment also. So this renewable energy technologies we can also call clean or green energy because they produce very few pollutants. Other than this burning of these fossil fuels, it sends greenhouse gases into the atmosphere and trapping the sun's heat and contributing to global warming. So climate scientists generally agree that the Earth average temperature has risen in the past century. So if this trend continues, sea levels will rise, and scientists predict that floods, heat waves, droughts, and other extreme weather conditions could occur more often. So this renewable energy will also help us develop energy independence and security. So it is plentiful and the technologies are improving all the time. So there are many ways to use this renewable energy. And nowadays we are already started this renewable energy in our daily lives. So in this slide, that's only, as I told, every coin has two sides. So some advantage and some disadvantage in the sources of energy, renewable and non-renewable, coal, oil, gas, nuclear power, and then types of energy in the this right hand side: wind energy, solar energy, hydro, bioenergy, and geothermal energy. So these are the advantages and disadvantages of this. The depletion of natural resources, as I discussed, see the graph in 2050. This curve will go down. So the present world oil reserve is about 1480 billion barrel, and the annual consumption is 32 billion barrel. So the expected depletion is about after 40 years. So there are some terms like bioenergy. So it is the energy derived from biomass, such as plants. If we ever burn wood in a fireplace or campfire, so we use bioenergy. But we don't get all of our biomass resources directly from trees or other plants. So many industries, such as those involved in construction or the processing of agricultural product, can create large quantities of unused or residual biomass, which can serve as a bioenergy source. Then in the biopower, there is one more term. So after this hydropower, which we use from the water, biomass is the second leading resources of renewable energy. So some utilities and power generating companies with coal power plants have found that replacing some coals with biomass is a low-cost option to reduce undesirable emissions. So as much as 15% of the coal may be replaced with biomass, and biomass has less sulfur than coal. So this less sulfur dioxide, which contribute to acid rain, and it is released into the air. So additionally, this boiler reduces nitrous oxide emissions, and this process is called our gasification. So the conversion of biomass into gas, which is burned into a gas turbine, is another way to generate electricity. Then there is a biofuels. So it can convert it directly into liquid fuels, that is called our biofuels. So because biofuels are easy to transport and possesses high energy density, they are favored to fuel vehicles and sometimes stationary power generations also. So the most common biofuel is ethanol. So an alcohol made from the fermentation, there is a one process of biomass high in carbohydrates. And the current largest source of ethanol is corn. So some cities use ethanol as a gasoline additives to help meet our air quality standards for ozone. And we can say blending fuel vehicles are also now on the market, which can use a mixture of gasoline and ethanol, such as E85. So it is a mixture of 85% of ethanol and 15% of gasoline. Another biofuel is our biodiesel, which can be made from the vegetable and animal fats. So biodiesel can be used to fuel a vehicle or as a fuel additives to reduce emissions. And this corn, ethanol, and biodiesel provide about 0.4% of the total liquid fuel markets. So to increase our available supply of biofuels, researchers are testing crop residues such as corn stalks, leaves, wood chips, food waste, grasses, and even trash of potential biofuel resources. So why we need this alternate fuel? So these are some points why we require and what is the importance of this alternate fuels. First, we know that this fast depletion of fossil fuels, it reduces of pollution caused by this fossil fuel. As I told, there is a sulfur content, protection against global warming, then increase in economy of the nation through emission in import, then local production of alternate fuels, meeting the demands in the global energy. And the last is India at present imports 3/4 of the total energy demands from other countries. These are some types of biofuels. Biofuels, alcohol. We can discuss one by one this biofuels, alcohols, hydrogen, natural gas, electricity, and propane. Before discussing these 6 types of biofuels, what are the uh, major constraint or challenges, or we can say what are the importance of transportation. So as we know, transportation is an extremely important element for the day-to-day functioning of any country. So without transportation, the entire country would in stable condition, or we can say standstill. So it is virtually impossible to imagine life without some form of transportation, like privately owned car, motorcycles, trucks, buses, subways, trains, planes, boats. These are all a daily part of our lives. So why we use these alternative fuels? So there is an environmental damage. This fossil fuel emissions from vehicles, it will damage the environment and contribute to air pollution. So there are some points which is related to major environmental problems like global warming, acid rain, air pollution, oil spills, health threat to fossil fuel use. So, in the global warming, it also known as the greenhouse gas effect. So, it is caused by an accumulation of carbon dioxide emission that do not leave the Earth's lower atmosphere. And this CO2 is the gas responsible for keeping the Earth climate warm because it absorbs radiation that would otherwise it will leave the Earth atmosphere and disperse into the upper atmosphere. So it is necessary to key in order to maintain a certain temperature that supports life on Earth. So an excess amount of CO2 in the Earth atmosphere is building up due to fossil fuel emissions that contain large quantities of CO2. So the CO2 has formed a thick blanket that traps heat near the Earth's surface, and these fossil fuels are the largest producer of CO2 emission, and the significant use of fossil fuel is thickening of the CO2 blanket over the Earth. So this blanket traps UV rays, that is our ultraviolet rays, that have been originally received by the Earth from the sun. Then oil spill, there is one more problem. So oil spill is a major environmental disaster, and it occurs when an oil tanker transporting oil to shore from an ocean-based oil rig sinks, and the oil cargo is released into the ocean. So oil spill can also occur when oil rig located in the ocean, and it will, due to some reason, accidentally leaks or exploits. So it is also important to note that when oil spill occurs on water, is extremely difficult to prevent the oil from spreading. It is also impossible to clean up an oil spills that occurs in water. So pollution to ocean is extensive, and countless fish, other valuable and beautiful forms of marine life and coastal lines are it is affected. So oil spill may not appear to be a major threat to the environment because they normally occurs in very remote areas. But the oil that is released into the ocean from an oil spill, it spreads very far and affects large areas of ocean life. So the oil reaches coastal land and destroy the animal and plants life that are part of our coastal ecosystem. So oil is a toxic and poisonous substance. It is important to remember that oil is retrieved from deep below the earth's surface, and it is not meant to be exposed directly to the environment because human, animal and plants life, the natural functioning of the atmosphere are not adapted to deal with the chemical composition of the fossil fuel. So another type of oil spill can occur when a land-based oil pipeline bursts and leaks. Unfortunately, oil spills occurs too frequently nowadays. Then there is acid rain. So this is an after effect of the use of oil and coal. So when oil or coal is burned through combustion in an engine, so that sulfur contained in the oil is released through the emission of the combustion and produces gaseous sulfur dioxide. So the amount of oil and coal used each day around the world produces a large quantity of sulfur as a result of the fuel combustion that takes place. So even though the sulfur content of fossil fuels is so slow, but millions of tons of sulfur are released into the air each year due to the heavy use of the fossil fuel. So globally, dioxide emissions are about 100 million tons annually and are increasing due to sudden third world industrialization. So due to complex chemical reaction that takes place into the atmosphere, this sulfur dioxide is transformed into sulfuric acid and nitrogen oxide is transferred into nitric acid. So these acids are found in the rain clouds and disseminated back to the earth's surface through precipitation, that is our rain and snow. So this polluted precipitation is acid rich and is collected in groundwater and released into rivers, lakes and the oceans. Not only does secondary pollution contaminate water on earth, it also causes other harm to the environment such as the destruction of valuable forest and contaminates human grown crops. Then we know this air pollution also. So in pollution basically defined as anything that causes a reduction in purity. So air pollution can be defined as the reduction in purity of the air. Most of the earth air pollution is caused directly as the result of emission from fossil fuels. So the process of combustion release gases and minute particles into the air. So all lives on earth depends on air for the basic respiratory process. So animals, plants, humans, we all depends on balanced amount of the gases that found in the air. So this water vapor, carbon dioxide, oxygen, these are the basic requirement of life. Since the gases and particles released from fossil fuel emissions are not naturally present in the air, therefore it is not compatible with the basic respiratory process that all forms of life have developed over millions of years. So when these foreign substances are introduced into the air, it is obvious that the natural balance of life on earth will be affected as the respiration process of all life on the planet are not adopted of these pollutant gases. So gases released from fossil fuel emission that cause the greenhouse effect are also polluting the air. That is our carbon dioxide, nitrogen oxide and methane. The three most prevalent greenhouse gases are also responsible for lowering the quality of the air that we breathe. PM, particulate matter, is also there. This is not a greenhouse gas, but it is also an air pollutant released from fossil fuel emission. So ozone is a gas that is created in the atmosphere by reaction between several of the gases released from fossil fuel emissions, and it is considered pollutants because it is a powerful irritant to the human respiratory system. Then there is a last health threat to fossil fuel. So this CO2 and NOx are poisonous gases that are dangerous to humans when we inhale. So these gases are produced mainly from mobile source emission, that is our vehicle exhaust emission. So children and the elderly are the most susceptible to developing asthma and other respiratory illness as a result of exposure to fossil fuel emissions. So cases of asthma and respiratory illness are increasing at alarming rates among the entire population because of the increase in the concentration of this carbon dioxide, nitrous oxide and particulate matter. So before going to this types of biofuel, there are some major challenges. What are the constraint and challenges? So Climate change, there's CO2 emission at highest level in the last 80,000 years, more than 2 degree expected by the 2100, with drastic consequences if nothing we can do. Then end of this fossil, or we can say depletion of fossil resources. So 97% of this road transportation uses fossil fuels. And oil, which is the main driver of our economy, might have disappeared by the end of the century. Then air pollution, with we know that the rural exodus and development of mega cities, air pollution has reached unprecedented levels. So serious health diseases to multiply drastically. Then constraint, there are some constraint like performance, infrastructure, and cost. So in the performance, we are taking main points like efficiency, acceleration, top speed, CO2 emission, and air pollution. Then there is a infrastructure. So in infrastructure, investment required to update existing infrastructure and to build a new one standard across all the overall the countries. Cost, total cost of ownership and maintenance also. Then there is a emission and emission norms. So the first emission norms were introduced in India in 1991 for petrol engine, and for diesel it was introduced in 1992. So basically the catalytic converter became mandatory for petrol vehicles and unleaded petrol was introduced in the market. So BSES, Bharat Stage Emission Standards, are emission standards instituted by the Government of India to regulate the output of air pollutants from CI engine and SI engine, including motor vehicles, compression ignition engine and spark ignition engine. So with appropriate fuel and technology, they limit the release of air pollutants such as nitrogen oxide, carbon monoxide, hydrocarbons, PM, particulate matter, and sulfur oxide from vehicle using IC engine. So basically, there are in the overall world there are two types of norms: Euro norms and BS norms. Euro norms they are using in European country, and BS norms for our India. So the Bharat stage norms have been styled to suit specific needs and demands for Indian conditions. So the differences lie essentially in environmental and geographical needs, even though the emission standards are exactly the same. For instance, if we are talking about Euro 3 tested at sub-zero temperature in European countries, but in India, where the average annual temperature ranges between 24 to 28 degrees Celsius. So another major distinction is in the maximum speed at which the vehicle is tested. So a speed of 90 km per hour is stipulated for BS3. But if we see in the Euro 3, so it is 120 km per hour, keeping other emission limits the same in both cases. In addition to this, the test procedure has certain finer points. For instance, the mass emission test measurement done in gram per kilometer on a chassis dynamometer requires a loading of 100 kg weight in the addition to unloaded car weight in Europe. But in India, BS3 norms require an extra loading of 150 kg weight to achieve the desired inertia weight, mainly due to our road conditions. So basically, sulfur content in the fuel, that is our petrol and diesel, BS3, BS4 and BS5 we have skipped, and now we are in BS6 from the April 2021. So the major difference in the emission, this sulfur content in BS3 is 350 in both petrol and diesel gram per kilometer, but in BS4 it reduces up to 50, and BS5 we have reduced, we have skipped, and now in BS6 it is only for 10. for petrol and diesel both. So these are the some table I have taken from my paper only, this one. And some norms is there for the permissible emission levels for gram per kilometer, CO, HC, NOx, and PM, particulate matter. So category is passenger car, light duty, heavy duty. This it is already published in one book chapter. Then we can discuss one by one this different types of biofuels. This is mainly from the natural gases found in plants and organic matter. Nowadays, ethanol is the main biofuel used today. It is made from an alcohol derivative that is obtained from the cooking and fermenting process of grain, that is usually corn. Most ethanol available is called E85, and this is a combination of 85% of ethanol and 15% of gasoline. So if you heard about Ford Taurus, so from 1998, all the Ford Taurus are manufactured. They are compatible for this E85. Generally, in our research point of view, we are optimized or we have to do blending up to only 20%. The rest we are doing up to 40, 60, and 80 also. But we have to check all the parameters, performance, combustion, and emission parameters for any engine, research engine that is used by the PG and PhD scholars and students. So we have to check what happens if we blend it up to 40, 60, and 80. But for all more than 100 blending we are doing in different category like edible oil, non-edible oil. There are a lot of category also. But up to 20% is optimum. Then alcohol, or we can say ethanol and methanol. So in this, alcohol type of fuel is alternative to petroleum-based fuels due to reduced greenhouse gas emission, this exhaust emission and enhancement of overall energy efficiency. So they are convenient for IC engine, internal combustion engine, due to their high octane rating, and we can say wider flammability limits also. So in order to achieve better environmental sustainability, it is the right time to use lower molecular weight alcohols, and we can replace this additives, other additives as octane boosters in automotive fuels in the present situation. Then there is a hydrogen. So hydrogen as an energy source for vehicles is still being developed, but is extremely promising. Hydrogen is the gas that can be created through electrolysis, the process of combining water and oxygen. So hydrogen is not only clean, it is also a renewable energy sources, and no fear of its depletion also. Just as gasoline is replaced into the tank of a traditional vehicle, so consumer may even be able to fill up at home if an appliances that generate hydrogen is developed, so that it is small enough and safe enough to store in garage. So no distribution system currently exists for hydrogen as a vehicular fuel source. So this is because hydrogen powered vehicles are not being marketed to consumer at this time. So US auto manufacturer as well as the Japan and Europeans are working to further develop and refine hydrogen powered automobiles. Once these vehicles are consumable ready, there will be a development of the hydrogen distribution system also. Then there is a natural gas. Although it is a fossil fuel, but it is considered to be an alternative energy source because it is a preferable alternative to oil. You can say why it is natural gas considered to be an alternative fuel. It's not a gas, it's a fossil fuel. So you are correct, but natural gas is a fossil fuel, but it is a different from gasoline or petroleum and coal because it does not contain the same harmful compounds found in other fossil fuels. Unlike gasoline, petroleum, and coal, natural gas has a negligible sulfur dioxide content, and it does not contain lead. So it has a low nitrogen dioxide content, and it also low particulate content and a low carbon monoxide content. So natural gas does not require uh, carcinogenic additives to boost octane levels, because natural gas is naturally high in octane, and it is still abundantly available, which means that is practical to rely on its continued supply for hundreds of years into the future also. Then electricity is one of the cleanest fuel, as it does not cause emission and pollution at the receiving end, although the production of the electricity energy may involve burning and combustion, which produces emission at source. So electricity is used to power vehicles by an electric motor, and electricity is provided to the vehicles by batteries that store electricity. So these batteries are recharged every day, normally in evening hours, or we can say in night when the vehicle is not being used. So the owner of an EV, electric vehicle, must recharge the vehicle from home using a small recharging station. Nowadays, no infrastructure for recharging stations exist in not any place in India. Only in America, there is a one state, California, has set up a recharging station in some areas. So EV cannot be used for traveling long distance, as there is difficult in locating recharging stations. Then there is a propane, so it is also known as LPG, liquefied petroleum gas, is a byproduct of processing of natural gas and crude oil. So now next is our biofuels generation and types. So before going to this biofuel, as we know, uh, it is energy made from living matter, usually plants, and this bioethanol, biodiesel, and biogas are the types of biofuels. So biofuels are considered renewable energies. It emit less than fossil fuels and have received increasing attention in the transition to a low carbon economy. So as I told, bioethanol, biodiesel, and biogas, these are the types of biofuels. So in the bioethanol, it is well-known biofuel, and it is an alcohol produced from corn, sugarcane, potatoes, wheat, even cornstalk, and vegetable waste. So it is commonly blended with gasoline. The plants grown specifically for any type of biofuels, and it is not ideal due to the energy required. We can say environmental impacts and emission associated with harvest and transport. So ethanol is the complicated issue, but overall is helping ease demand on fossil fuel. There are two countries, Brazil and the US. United States are the biggest exporter and consumer of this ethanol. Then biodiesel, it is basically from plants or animals used as an alternative to or blended with petroleum diesel in automobiles and industrial fleets with diesel engines. So the leading exporter of this biodiesel is Argentina. So the US creates its own biodiesel as well. Then this biogas, it is created as a byproduct of decomposing plant and animals waste in environments with low levels of oxygen. So biogas basically made up primarily of methane and carbon dioxide. So the natural incentives are strong to keep biogas from entering the atmosphere. In practice, biogas is not captured and used as much as it should be, despite being used for centuries. So it can be used for transportation, cooking, and electricity. And it will play an increasing role in the transition of low carbon economy due to its ability to capture greenhouse gas emission and reduce waste, and creating energy from a byproduct of other activities also. So in the first generation biofuels, these are directly related to biomass that is generally edible. Second generation biofuels are defined as fuels produced from a wide array of different feedstock ranging from uh, lignocellulose feedstock to municipal solid waste. Then there is a third generation. So in the third generation biofuels, at this point it is related to algal biomass that we can see in the काई जिसको हम हिंदी में बोलते हैं. It could to a certain extent be linked to utilization of this our CO2 as a feedstock also. So India first biofuel powered flight that aims to reduce cost of air travel by replacing the costly aviation turbine fuel was successfully tested. So in this 72 seater SpiceJet aircraft, partially powered by this biojet fuel, sorry, and it took off from Dehradun and landed at the Delhi airport. So the duration of flight was around only 25 to 30 minutes. Now I'm working last 3 to 4 years on this micro algae, and this undercomes in the third generation. Basically, in the microalgae, it contains lipids and fatty acids over 30%. So it can be easily grown in sewage and industrial pollutants also. So we can discuss how I am working in this through numerical also. Most of the paper is related to numerical work and experimental work also. So for that, at least we have one engine, we can say research engine, that will be used by only for PG and PhD students and candidates. So before joining to this institute, I was working in NIT Manipur. So there I have one engine that is related to Legion Brother. The company name is Legion Brother, and the engine name is MFVCR, that is multi-fuel variable compression ratio. So in this MFVCR, basically we can use petrol, diesel, gasoline, and blended also. So as we know that for the SI spark ignition engine, the compression ratio is 6:10, and for the CI engine is, in some books it is given 15:20, or in some books 16:20. So manually we have to change that compression ratio, and we can check all the parameters, that is performance, combustion, and emission. There are some categories or some points we can discuss if time permits. It is a conversion of this fourth generation. It is a conversion of first, second, and third generation of biofuels. Then biodiesel. Biodiesel, it is a form of diesel, that is fuel derived from plants or animals, and consisting of long chain fatty acid esters. It is typically made up by chemically reacting lipids such as animal fats, soybean oils, or some other vegetable oil with an alcohol producing ethyl, methyl, and propyl ester. So a clean burning alternative fuels for diesel engine produced from domestic renewable resources such as vegetables oils like soybean oil or animal fat. So they do not contain petroleum compounds that can be blended with diesel to create blends. As I told कि 20% तक optimum रहता है ये. After 20% we can use to check the engine characteristics, that performance, combustion, and emission. So these are the advantages. If we are using B100, so you can see the greenhouse gas emission is only up to 30. This diesel is around 100. then LPG is more than 100. So the exhaust gases are less harmful to the environment by producing less HC, hydrocarbons, carbon monoxide, and particulate matter. So this one process, it is well-known process, transesterification. There is one chemical reaction to create or to produce biodiesel. Everywhere in every paper which is related to biodiesel, we can see this process, transesterification. Basically, we are doing to in this process to reduce the viscosity of oil for this process. This spice jet जो मैंने आपको बताया कि there is a first biofuel. It took off from Dehradun and it will landed on Delhi airport, and the duration of flight is around 25 to 30 minutes. Then in this slide, basically, I want to show ki, how we can categorize this edible, non-edible. So you can see this, some properties is also there, density, viscosity, these are the basic properties of biodiesel. We can check from different equipments. Density meter is there, viscometer is there, cetane number, flash point. So in the edible biodiesel, there are coconut, palm, rapeseed, soybean, and sunflower. Then in the non-edible biodiesel, cottonseed, jatropha, karanja, and microalgae. So my candidates are working on this microalgae. Again, microalgae, there are a lot of categories. More than 50 species are there. So we are basically working on spirulina microalgae. So in one paper, I have discussed how we can prepare and how we can check the performance and combustion and emission parameter to our engine. Then there is various animal fats, that's beef oil, chicken fat, fish oil, lard oil, poultry, wheel. Then waste oil. Waste oil, we can take that grease, waste cooking oil, waste frying oil, and last alcohol biodiesel. So this all data I have taken from my paper only, that was published in ECM, that is Energy Conversion and Management, in 2018. So in the various this alcohol biodiesel, butanol, ethanol, methanol, propanol, and pentanol, in this category, same we can before going to the engine, we have to check all these properties like density, viscosity, calorific value, cetane number, flash point, carbon, hydrogen, oxygen. These we have to check. If we are doing any numerical work, so before going to the numerical, I think most of the student and faculty know, we have to do first validation. Without validation, we can't go for our directly to the numerical work. So validation is basically two types. Best of my knowledge, ki first we have to do any experiment, the same boundary condition, same
Hello,
everything
sir.
we have to.
Hello.
Hello.
Sorry for interruption, sir. Actually, the prompts are not very visible, sir. Participants are requesting to switch the PDF into full form.
Okay, this PPT. Just a second. Now it's okay?
No, sir.
I have done the full screen.
Sir, please put the slideshow in full screen, sir.
Just a second. Now?
No, sir.
Still, so just a second. मैं ना पहले इसको एक बार क्लोज करता हूँ. Now it is okay, or still it is on not full screen?
Sir, no issue. Actually, that part was only not clear. Baki others are very good.
Okay, but now I have done full screen also, no? From my
No,
end.
sir, it is not, sir.
Okay, I'll try
Sir, there
one
is
more
no
time.
issue, sir.
Okay. So we are discussing कि अगर if we are doing any numerical work. So in numerical work, first we have to do validation. Validation is two types, as I told. First, we have to do any experimental work. So all the boundary condition is same. We have to apply in our numerical work. Any software you can use, ANSYS, or my candidates are working on Diesel Arc. It is available in internet. It is free. There is a no cost. If there is a basically, it will give the results in the Excel form, and we can draw in any good plotting software like TechPlot or Origin. So in Diesel RK, basically this numerical, we can say the combustion model in this, it includes the self-ignition delay calculation, and it based on the detailed chemistry simulation of methanol pre-combustion reaction. And other than evaporation of methanol droplets, methanol fuel spray penetration, spray angle, droplet forming, and others also. So the developed computer code allows engineers to account for the arbitrary shape of the combustion chamber also. So in each fuel system, it may include several injectors with arbitrary oriented nozzle with different diameters and central of site location in the combustion chamber also. So in the model, each fuel spray is split into a number of specific zones with different evaporation conditions. So these zones form on the cylinder liner surface and on the cylinder head are also taken into account. So the piston ball in the modeling process is assumed to have an arbitrary axis symmetric shape, and the combustion model supports central, non-central, and side injection system also. So in this basically for NOx calculation, submodel use detailed chemistry analysis, which considers 199 reactions of 33 species. And other than this, also soot formation calculation submodel used is a phenological one and takes into account the distribution of the droplets. There is a SMD, outer mean diameter during the injection process, and the ignition delay period we can calculate. So each fuel system may include several injectors with arbitrary oriented nozzle with different diameter and central, off central, and side location. So जैसा कि मैं डिस्कस कर रहा था कि we can validate first. So our experimental and our numerical work, or we can choose any previous paper which was published 5 years back, 10 years back, even 20 years back also. So for that also we can take experimental data for that paper. All the boundary condition will be same in the numerical work, and then if the results are correlate, then we can do our numerical work for new boundary condition. Even you can change the biodiesel also, even you can change the load, uh, RPM, fuel injection pressure, everything you can change. But before going to any numerical work, please do the validation part. So these results are not related to uh, any numerical work. Again, I have taken this from my published paper. So in this, basically some instrument before going to the engine, we have to check what are the feasibility, what are the properties for the biodiesel. So These all result related to GCMS, FTIR, and SEN. So basically, GCMS is extensively used for the analysis of these compounds, which includes ester, fatty acids, alcohols, aldehydes, and terpenes. So it is also used to detect the measure contaminants from spoilage or adulteration, which may be harmful and which is often controlled by government agencies. For example, we can say pesticides. Then there is FTIR, Fourier transform infrared spectroscopy. It is also known as FTIR analysis or FTIR spectroscopy. It is an analytical techniques used to identify organic, polymeric, and in some cases inorganic materials. This FTIR analysis, it uses infrared light to scan test samples and observe chemical properties. Then there is a SEM. So the full form of this is scanning electron microscope, and it scans a focused electron beam over a surface to create an image. The electron in the beam interact with the sample, and it producing various signals that can be used to obtain information about the surface topology and composition. So in this, I have taken this waste cooking oil. There are two types of catalyst, heterogeneous and homogeneous. You can see in the picture also, there is a river mussel shells. It is easily available in Manipur, Imphal. So at that time, one of my candidate have used this river mussel shell, and these results are different. जो मैंने आपको दिखाया टेबलर फॉर्म में, so it is only for the emission parameter I have taken NOx emission for the 5 different category, like our edible, non-edible, vegetable, animal fats, waste oil, and alcohol. So these are results related to that. Just a second. So there is one more, EDX is also there. So it is an analytical technique which is used for the elemental analysis or chemical characterization of a sample. So the number and energy of the X-ray emitted from a specimen can be measured by an energy dispersive spectrometer. Then XRD is also there. XRD basically we can use, it is a rapid analytical technique and used for phase identification of a crystalline material, and it can provide information on unit cell dimensions, and the material is finely ground, homogenized, and average bulk composition is determined. So in this, as I told you, there are some basic properties which we have to check, like suppose calorific value, as we know that this is the amount of energy released for, or we can say produced when 1 kg of fuel burns, or any other substance is burned in the presence of oxygen, and the products of combust are cooled at STP, that is our unit is our kilojoule per kg. Then there is a C10 number. So basically C10 number, the combustion speed of diesel fuel and compression needed for ignition. So it plays a similar role for diesel as octane rating, and it is also known as C10 rating or C10 number. So it is a measurement of the quality or we can say performance of diesel fuel. So the higher the number, the better the fuel burns within the engine of a vehicle. So in other words, we can say it is how minimize the delay. There are two types of delay, physical delay and chemical delay. So the delay is between when the fuel is injected into the chamber and when the combustion begins. Flash point, the lowest temperature at which a liquid will form a vapor in the air near its surface that will flash or ignite. It is general indication of flammability or combustibility of a liquid. Then pour point, it is the temperature below which the liquid loses its flow characteristics. So in crude oil, high pour point is generally associated with a high paraffin content, typically found in crude deriving from a large proportion of plant material. So this we can use a reactor also. So it is just a tank with a heating element or a pump or a motor. So these are result related to that NOx, then PM emission. All the graphs are we can plot nowadays, not in Excel. So please don't nowadays use Excel for drawing any type of plot. Only use any good plotting software like Origin or TechPlot or other also it is there. So all this in tabular form, this NOx, PM, smoke, and summary of emission. Then this is the line diagram of GCMS. Then FTIR. Some standards for this instrumentation for this biofuel research. ASTM, American Society for Testing and Materials. So we have to follow that standard also. Then conclusion, as I told, there is a few results I have shown. So the alternate source of energy are eco-friendly and less harmful to the environment as compared to conventional fuel. And the level of air pollution may also be reduced by using alternate fuel. The present scenario of global warming can also be reduced by using this alternate energy sources. Since these alternate energy sources are renewable in nature, they can be used extensively without much effect to the environment. And then last, these steps can help in conserving our natural resources. So this general conclusion. Thank you for your patience. If anyone have any doubt regarding this topic, so you can ask or you can drop a message, you can call me, you can mail me. Other than this, if anyone wants to work in this area, so you can directly contact me. I think in your institute, Dr. Mayank Sharma is there, so you can take my number from him.
Yes, sir. Sure, sir.
Any combination, or we can do some work also if any student or scholar is there and work in this area. So any query regarding this, so please ask.
Dinesh Kumar raised a hand.
Thank you, sir. Such a novel and mind-blowing session. I will request you all to please ask if you have any queries, or you can write it on chat box also. Everyone is welcome.
Good afternoon, sir.
Yes, good afternoon, Ravi. Please.
Yes, sir. Sir, I had a question. Why biofuels like Ratan Jot are not seen as alternative fuels?
See, Imtiaz, as I told कि कोई भी चीज का we can take some advantage and disadvantages. So there are a lot of parameters which we have to check. So like for engine point of view, there is 3 parameters: performance, combustion, and emission. But other than this, we have to check the availability also in that area, whether it is available in abundant quantity or not. Maybe there is some properties which we have discussed, like density, surface tension, viscosity, flash point, pour point. So it will meet at least near to the diesel when we are doing the blending. As I told, up to 20% we can blend. Researchers are doing more than 20% also. Even I am also using 40, 60 and 80 and even 100% also. But government has decided up to 20% is optimum and we can get the best result also up to 20 only. So in Ratanjot, maybe there is some problem. Basically, we are doing in the uh, transterification process, we are doing the lowering the viscosity of the biodiesel or biofuels. So when we go to this Ratanjot, exactly I'm not using this Ratanjot, so there is possibility ki whatever properties in the Ratanjot, it is not comfortable or it is not matching with the diesel, so that we cannot blend or we can use in our research engine, or we can say any engine.
Okay, sir. Thank you, sir.
Thank you, sir. Dinesh Kumar sir has raised his hand. Sir, you can
Yes,
ask your
please.
question, sir. Dinesh sir, I will request you to please ask your question.
Other than this, if anyone want work in the diesel RK, it is easily available in the internet, and you can learn or you can work easily with the help of YouTube, or there is a help file is also there. Basically, we are putting in that diesel RK two things. The first, engine parameters, not parameters, what we have in the engine, like our inputs, load, compression ratio, fuel injection pressure, how many nozzles we have in the engine. And the second, whatever biodiesel or biofuel we have used, that properties we need. If we have these two things, so we can check the performance, combustion and emission parameter for any biodiesel. So a lot of paper which my candidates published, that is related to diesel RK, and 30 to 40% are related to experimental also. But you can check how we can do that numerical work. It is very easy also, and it is there is no cost. You need no need to purchase this diesel RK. Any doubt, then please.
Hello, sir. Sir,
Yes, Pulkit.
actually, sir, as you have told, the most common types of biofuels that are used today are ethanol or biodiesel. Sir, both are first generation biofuel technology, sir, but in the trend, sir, ethanol blending has been started. Yes, sir, like 7%, 6% to 7% kind of that. And sir, there's a lot of scope in ethanol blending also. Sir, what is the source of ethanol actually, and how it will benefit India, sir? In India, sir, how can we obtain ethanol, sir? Do we have to export it, or in India the resources are present for ethanol, for
Corn,
production of
corn,
ethanol?
CORN. Corn is the best resource for ethanol.
Okay,
So no need
thank you.
to, we have to take from other country. We can generate, we can use in our diesel, and up to, as you told, 7 to 8, but we can use up to 20% also. There is no
Okay, sir,
problem.
thank you.
So most of the researcher or the last 20 to 30 years, whatever biodiesel we have used up to 20%, we can use directly to in our engine. So there is no need of any modification in the engine. So as I told कि जो हमारा experimental setup होता है, so if we blend, so there is a no up to 20%, no need to do any modification in the engine. After 20%, we have to do modification also in our engine.
Thank you, sir. Sir, there is one more question from Kishore Kumar Sahu, sir. His question is, which are the most promising approaches for improving the production and use of renewable?
So which are the most promising approaches for improving the production? See, production method is our transterification process. There is one chemical reaction to reduce the viscosity. Basically, we are in that chemical reaction and chemical process, we are doing the, or we are focusing to do the lowering the viscosity. So that is also one of the best method, and you can see in any paper those who are working in that. So one of the best method is transterification process. Then there is a reactor also. So from that reactor also we can produce, but that one is little bit costly. So some institute or very rare institute that they have this reactor, and it is costly also. Kishore, any doubt?
Thank you so much, sir. This answer all our questions. Now we have come to the end of this session. We would like to convey our heartiest thanks to Dr. T.N. Verma, sir, for such an exciting session. This was a supreme paradigm of why this kind of interaction is crucial. We are thankful, sir, for enlightening us. Sir, one last request, please.
Yes, please.
Hello. Sir, may you please share your PDF with us, sir? It will be beneficial for all the participants.
Okay, definitely. I'll mail to this Dr. Mayank. You can take from
Sure,
him.
sir. Thank you so much, sir.
Thank you.
Thank you, Tikendra sir. Thank you very much. Yeah, Dr. Mayank.
Yeah, Dr. Sharma.
Thank you, sir.
Thank you so much.
Thank you so much, everyone, for joining us. We will meet you all tomorrow, that is 19th August, exactly at 9:30 a.m.